two equations that are applicable to projectile motions. In case you had missed any of our previous videos on projectiles, I'll encourage you go look up those videos, watch them today, and let's go straight. Here we have the same sketch we had used previously, so we will recall another equation whose video we had posted on uniformly accelerated motion on the horizontal plane. Go look up those videos as well, watch them to the end. Here we have that S, S equals to ut plus half at squared. This is for uniformly accelerated motion on the horizontal plane. But because we are looking at motion in space, we will replace this, take note, with h. We will have capital letter H. And since the object is going up, as it is shown here, we replace this with a negative sign because acceleration due to gravity will be negative. We had explained that also, please, in the previous video, all the explanations we need. So this is what we are going to use. Here, we need to get an equation for maximum height. Here, what happens there? The component of initial velocity in the vertical plane, we derived that in the previous video. So we substitute that. That will be u sine theta. And then time, okay? Time will be time taken to get to maximum height. That will be u sine theta over g. You remember that u sine theta over g. Okay, and still at maximum height, we are looking at what happens here. Here again, we will have minus half. G will still be the acceleration due to gravity. We will square this, the same value of time we had used, okay, from equation 1. Watch our previous video, you see that this becomes u square, u sine theta, u sine theta over g, all square. So we are picking the value for small letter t, the time taken to get to maximum height from our previous video. We are just putting it there. Now we work this out, we'll end up having u square sine square theta over g. If you resolve this, u times u square sine theta sine square theta. If you work this out, you end up having minus half u square sine square theta over g. That is, if you resolve this, that's what you are going to have, okay? So u square sine square theta over g minus half u square sine square theta. So we end up having, as a result, u square sine square theta over g. There's a 2 here, so it's going to be 2g. That's h max. So we have that our maximum height, for the particular projectile, when the object gets here, how do you get that maximum height? The formula or the equation will be u square sine square theta all over 2g. That's the equation for maximum height. Now, if recall from trigonometry, the greatest value of sine theta is 1. So if we are supposed to have 1 here, that means theta will be 90 degrees. Sine 90 rather is 1. So theta will be 90 degrees, so that we will have 1 here. And that will leave us with u square over 2g. That means if you want to attain maximum height, the angle of projection should be 90 degrees. In other words, the object should be projected perpendicularly to the horizontal plane. Okay, in our next video, we will derive the remaining equation. In case you've not clicked the follow button yet, do well to click our follow button, tag friends and associates, and share our videos so that others can benefit. Thank you.